Hello again, WHS Juniors, reviewing for your MCA. This MCA lesson is all about angle properties of parallel lines cut by a transversal. So first, we're going to start off with definitions of some terminology that you need to remember. Number one, first of all, what is a transversal? Well, a transversal is a line that intersects two or more coplanar lines at different points. So let's take a look at the picture. A and B are coplanar lines that are cut by this line T. Line T is intersecting two different lines at two different points. T is a transversal. Next definition, corresponding angles are any two angles that correspond in the same position. They occupy the same position, if you will. Let's take a look. Oh, let's get our magic pen out here. If we look at just this intersection, we see that number one is in the top left corner. So angle 1 is in the top left corner. If we slide this down to the next intersection, angle 5 is in the top left corner. So that means because angle 1 is in the top left and angle 5 is in the top left, they're corresponding. Let's take a look at another one. How about number 2? It's in the top right. So is number 6. So 2 and 6 would be corresponding. So we're looking for the same position, different intersections. So top lefts, top rights, bottoms. Let's list them. So our transversal, if we're going back, that was line T. Corresponding would be angle 1 and angle 5. Or we could think of it as angle 2 and angle 6. Or there's even another one. We could have angle 3 and angle 7. Or, yes, there's another one, angle 4 and angle 8. So there are actually 4 pairs of corresponding angles in that picture. So, same position, different intersection. That's what you should remember. Next one are the alternate exterior angles. Alternate exterior angles are any two angles that lie outside of the two lines and opposite sides of the transversals. So when we say outside, if we look, here's two lines. The inside is, well, where my hands would meet. So let's highlight that. This would be considered inside. The yellow is inside. And the green would be outside. So, alternate exterior angles are two angles that lie outside of the two lines on opposite sides of the transversals. So those would be angles 1 and angle 8, or angle 2 and angle 7. Notice I'm not talking about 1 and 2. 1 and 2 are a linear pair, which we'll review in just a second. We're talking about 1 and 8, or angles 2 and 7. So 1 and 8 or 2 and 7. Next one, alternate interior angles. Good thing we just highlighted all of our interior angles. So alternate interior angles are two angles that lie between the two lines on opposite sides of the transversals. So in this case, we're talking about 3 and 6, or 4 and 5. So angle 3 and angle 6, or angle 4 and angle 5. Okay, going well. Let's talk about consecutive interior angles. They're also known as same-side interior. Maybe they're more often called same-side interior angles. They're two angles that lie between the two lines on the same side of the transversal. So if this is our transversal, notice 3 and 5 are on the same side. They're both on the left-hand side of the transversal. Just like 4 and 6 are on the right-hand side of the transversal. So we have two pairs of same-side interior angles, and they're angle 3 and angle 5 are same-side interior. Or there's another pair, angle 4 and angle 6. Okay, let's remind ourselves of a couple of terms that I just got done talking about. And those are linear pairs and vertical angles. So linear pairs, if we remember, sorry, trying to get the picture in here. Linear pairs are a pair of adjacent angles whose non-common sides are opposite. What that means is adjacent means they're sitting right by each other, and their opposite sides Well, their non-common sides being opposite means they make a straight line. So in the picture, there's actually a lot of linear pairs. Linear pairs are two angles that make a straight line. So 1 and 2 are a linear pair. 2 and 4 are a linear pair. 3 and 4 are a linear pair. 1 and 3 are a linear pair. And we're not done yet. 5 and 6, linear pair. 6 and 8, linear pair. 7, 8, linear pair. 5 and 7, linear pair. There are 8 linear pairs in this picture. Next, vertical angles. They are non-adjacent angles formed by two intersecting lines. So if two lines intersect, the only two that are non-adjacent, meaning not touching, not sitting side by side, are angles like this, 1 and 4. 2 and 3 are vertical. 5 and 8 are vertical. 6 and 7 are vertical. So in this picture alone, we can describe a whole lot of angles. We have corresponding angles, alternate exterior angles, alternate interior angles, same side interior angles, linear pairs, and vertical angles. That's 6 different kinds of angles we can get from just this one picture. And you're going to be expected to know all of them. So let's give it a try. Here's a bigger picture. We have actually 4 lines here and 10 different questions, and we are asked to identify each pair of angles. So in looking at the picture, you should be able to identify what type of angles they are. So let's get started. 1 and 4. They're on the same intersection and they're non-adjacent, meaning they're right across from each other. Those are vertical angles. All right, 7 and 8. 7 and 8 are on the same intersection, but they are adjacent. They're right by each other. They're touching. That's a linear pair. Okay, 3 and 6. Here's 3, here's 6, which means we are stuck looking at this intersection. N is going to be our transversal. If N is our transversal, we have to decide how are 3 and 6 related. And in this picture, 3 and 6 are interiors, and they're alternate exteriors because they're on opposite sides. So we have alternate interior angles. Not sure if I just said exterior. I didn't mean it. They're inside the 2 lines. They are alternate interior angles. Let's try the next one, 11 and 15. If you notice, 11 and 15 are on this intersection, which means they are, if you notice, both in the same lower left-hand position, so they are corresponding angles. Okay, 2 and 10. 2 and 10. Whoop, magic pen. There we go. 2 and 10 are both in the upper right-hand corners, so they are corresponding angles. Okay, 12 and 13. We're going to forget the magic pen. I think we can make this work. These are both interior of this intersection, but they are on alternate sides, so they are alternate interior angles. Next one, 11 and 13. They are again on this intersection. P is the transversal, 11 and 13. They are on the same side interior angles. Next one, 9 and 16. 9 and 16 are alternate exterior angles. They're on alternate sides of the exterior. Next one, 7 and 14. 7 and 14, we're looking at this intersection. These are actually exterior this time. 14 becomes exterior when looking at M as the transversal. 7 and 14 are alternate exterior angles. All right, last set. 8 and 13, same intersection. 8 and 13 now become the inside, the interior of this transversal, cutting through these lines. So 8 and 13 are alternate interior angles. Okay, hopefully that went well for you. Now, if you can identify angles, you can also tell me why angles may be congruent. Let's talk through this. It says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So what that says is if lines are parallel, then the corresponding angles are congruent every time. Same with alternate interior angles theorem. It says if lines are parallel. Notice we're going to keep starting with if lines are parallel. We have to have parallel lines. If that's true, then alternate interior angles are also congruent. They're the same angle, same measure. Consecutive interior angles, same thing. If two lines are parallel, then consecutive interior angles are supplementary. This one's a little bit different because they're the same side interior. If you look, most of the time you can tell. One's acute and one's obtuse. They're obviously not the same, but they are supplementary, meaning they add up to 180 degrees. Last one, alternate exterior angles. If two parallel lines, once again, are cut by transversal, then the pairs of alternate exterior angles are congruent. So we have congruence when we are given two parallel lines. The angles that will be congruent are the corresponding angles, alternate exterior, alternate interior. Those are all going to be congruent. And consecutive interior or same side interior are going to be supplementary. Let's give that a try. So what we can do is if we are given two lines cut by a transversal and we know one angle, we should actually be able to solve for all other angles in that picture. Let's give it a try. I'm going to go ahead and take our given information, the fact that the measure of angle 2 is 110 degrees. I'm going to go ahead and write that in. We should be able to find all the other angle measures, and we should be able to state a reason why we know that. Well, angle 8, here's what I see. Angle 2 and angle 8 are a linear pair. What we should know about linear pairs is they add up to 180 degrees. So if these two are supposed to add up to 180 and this one's 110, how much more do I need? Well, the answer is 70. And how do I know that? Is because that's the linear pair postulate, or linear pair theorem if you've been taught that way. But it's because they are linear pairs. Now, let's look at measure of angle 1. There are two ways to do this. Best way, though, is to look at 8 and 1. They are corresponding angles. And these lines, P and Q, are parallel. So if they're parallel, then these angles are congruent, which means I automatically know angle 1 is 70 degrees. Because I have parallel lines cut by a transversal, those corresponding angles are congruent. And the reason is because of the corresponding angles postulate. Next one, angle 3. Well, angle 1 and angle 3 are a linear pair, which means they add up to 180. So I could subtract from 180, and I would be left with 110. Or, another way to think about it is that 3 and 2 are alternate exterior angles. And again, we have parallel lines cut by a transversal. Those alternate exterior angles are going to be congruent. 3 and 2, same angle. So that's actually what I have written down here. It's going to be 110 degrees, but for one of two reasons. Either because of the alternate exterior angles theorem or the linear pair postulate. Okay, last one. They want to know, what's angle 4? Well, angle 4 is going to be 70 degrees. Couple reasons why I know that. Number 1, linear pairs. I can subtract from 180. Another reason, these are vertical angles. All vertical angles are congruent. Another one, these are alternate exterior. Alternate exterior angles are congruent if we have those parallel lines. So what I know is angle 4 is going to be 70 degrees for one of three reasons. Because of the alternate exterior angles theorem, the linear pair postulate, or because of the vertical angles theorem. Okay, let's keep going. Let's try this again. Let's try to find the measures of three angles given one angle. So we're going to be asked to find the measure of angle 1, measure of angle 2, and the measure of angle 3 when we are given that lines AB and CD are parallel. So AB and CD are parallel. And AC and BD are parallel. So these ones are also parallel to each other. Okay, let's find some angles. Here we go. If this is 110 degrees, if these two lines are parallel, angle 1 and 180 degrees are same side interior angles, meaning they are supplementary. Supplementary means they add up to 180. So what number plus 100 would add up to 180? Well, the measure of angle 1 is going to have to be 80 degrees. Okay, let's try another one. Let's try angle 2. This 100 degrees that we were given in angle 2 are actually alternate interior angles. If we notice, they're on opposite sides of the transversal on the inside. They're alternate interior angles. And if we have parallel lines, those alternate interior angles are congruent. So no math needed, just a few definitions, and we know that the measure of angle 2 is 100 degrees. Okay, let's look at the angle 3. Angle 3 and angle 1 are corresponding angles. I already did the work to find